coming to you today with another floor equation. This time it involves a transcendental function, a function that doesn't have any algebraic. It's difficult to solve algebraically, basically. There's a more technical definition. But anyway, we have the floor of the natural log of x squared is equal to just a linear function. Now right here, it's important to realize this right-hand side is not a floor. It's just a line. So you don't have to worry about the floor of 3x minus 15. Now we're searching for positive solutions in the interval 0 to infinity, open 0. Now, there's a very crucial lemma that I'm fond of doing it this way. You could think about it at each stage, or you could just create a lemma. And if you take a look at this lemma, k is a positive integer, or you could call it a natural number. Now, if you just pay attention to the laws of exponents here, this one's easy. This is an increasing function. The logarithm function increases, albeit slowly. But if you take a look here, x is a member of e to the k over 2, comma, e to the k plus 1 over 2. And you're going, what? Where did that come from? Well, it really just follows from the fact that ln in the exponential function are inverses and also properties of exponents. Envision this x over 2 being placed in here for x. By properties of exponents, you would have k over 2 times 2, which is just k. So in that sense, it's very, very easy. Now we have to leave out k plus 1 over 2, because by the very same reasoning, if we tried to include k plus 1 over 2, that would mean that k plus 1 would also be part of this, all right? And so we're just trying to confine this to a single integer floor level, all right? So this very powerful lemma, coupled with just a little bit of algebra here, if you solve 3x minus 15 equals to k, you get k plus 15 over 3. And so really, we can just answer this question by answering this question right here. Okay, now it turns out to be a case-by-case process here. It's nothing special about it, but anytime we find a k, the value of k such that this expression is contained in this interval, by these two results here, we will have a solution. Okay, so it's really now at this point, it's just kind of tedious. Now for k equals 1, it's fairly straightforward. K equals 1 would give you 16 over 3, right? 16 over 3. Well, it's clear that 16 over 3 couldn't be contained in e to the 1/2, e to the first. Again, using this lemma right here, because 16 over 3 is much larger than e, right? E is approximately 2.7, okay? And so without using a calculator, we know that k equals 1 is not going to provide a solution. Now, in a similar fashion, if we try k equals 2, this would be 17 over 3. But 17 over 3 is not going to be in this interval. It takes a little more work. But notice here that I just stated it wasn't in there, and here's the justification. 17 over 3 squared is greater than e over 3/2 squared, right? Which is just e to the e cubed. Now again, you'd have to do the arithmetic here, but this number is substantially bigger than e cubed. E cubed couldn't be any bigger than 27, right? Because 2.7 is 2.7 something is e, so raise it, just consider it 3. 3 cubed is 27, which is much larger actually than e cubed itself. But this 17 over 3 squared is bigger than that. So we can, and I didn't write the arithmetic down just to avoid the clutter. But anyway, so we know that for k equals 2, there are no solutions. Now we get lucky. When k is equal to 3, 18 over 3 is just 6, okay? Now this takes a little more work, folks. 6 is less than e squared. Now notice, remember e is approximately 2.7 something. So I just used a smaller number, which is gonna be stronger, okay? So we get that 6 is less than 2.5 squared, which would be less than e squared. E squared is approximately 2.7, right? So you see, we've shown that 6 is less than e squared, meaning 6 is contained in this interval. We've already shown back here that it can't be. You can use this back here to verify that it can't be less than e to the 3/2. So 6 is definitely a solution. Okay, progress. Now let's go on one more level. Now this took a little more work, but I tried it for 4. And again, we use this estimate. I use 26 over 10 as an estimate for 2.7, and it's a smaller estimate. So for similar reasons, we can conclude that there are no solutions in this interval right here, the interval from e squared to e to the 3/2. And because e outgrows this linear function by so much, we can stop. Now, I know that's not a rigorous proof, but I could write a little bit more, but I think hopefully you guys are convinced that it would be even more of a distance between the two interval solutions if you did k equals 5, k equals 6. So we have a single solution, folks. X equals 6 is the only solution to this expression, provided we're doing positive numbers. There may be solutions for negative numbers. I may do a video on that. Okay, hope you guys enjoy.